Today's session is all about battery management system and battery modeling. Okay. Today's session is pure technical session. We'll be touching some core fundamentals. We'll be talking about what is battery management system at the first place and what is your cell modeling. Okay. So let's start with this. I think people are very much excited about it. 100 people approximately has joined. They're asking multiple questions in the beginning of the session itself. Good. Good to see the spirit. Yeah, good morning, everyone. Let's start now. Okay. So let's see what's the agenda for today. So first, we'll be covering the basic fundamental of battery management system. What is a battery management system? What is a SoC algorithm? Then we'll be talking about different battery modeling techniques, SoC algorithm techniques. Then Lokesh will take us through in a live demo on a MATLAB how to do RC modeling and how the SoC estimation technique works. At the end of the session, we'll give a brief introduction about what is Techlanz. This is all about today's agenda. We'll be focusing around 50 to 55 minutes on the top three sections. Okay, and 30 minutes approximately we'll be spending on the MATLAB demo itself. So stay tuned till the end of the session where Lokesh will take you through the complete modeling of it and will give you hands-on training on that particular subject. Okay, so today's speakers, me, 𝐓𝐨𝐻𝐬 𝐂𝐨𝐯𝐞𝐫𝐞𝐝 and Lokesh Soni are the co-founder of Techlanz. We both come with the IIT background, alumni background. We both have experience of 10 plus X in the industry. We worked with Mahindra and Mahindra, Ather, Mercedes-Benz, ZF, Simple, right? And with that vision, we started Techlanz to start something new in the technology domain since we are coming from the EV background itself. So first of all, what is a battery management system and why it's required? So battery inherently, if you know, they are very sensitive, right? They have a very sweet spot of operating in a voltage range. You cannot overcharge a battery. You cannot undercharge a battery. They have operating band. Similarly, for the temperature also, they have a sweet operating band for the temperature as well. The temperature for a battery shall not go beyond a certain temperature and should not also go below a certain temperature for sweet operating points. So many less people know there is an under voltage limit, under temperature limit also for the battery. For suppose if you're operating a battery in sub-zero condition, you cannot charge a battery, right? So then you need some kind of heaters to heat the battery first so that you can charge the battery packs. With this, so you understand there are many constraints on a battery pack, right? So there are many constraints on a battery pack. Now, let's understand that how these constraints are managed, right? So there is a something battery management system which takes care of all these constraints while operating the battery at its optimum conditions. So all the power which goes to the battery or comes out of the battery goes through a BMS, and all the battery signals like voltage, temperature, current, everything is being monitored by the battery management system. Now, if you see that way, so all the external supply of the power or the signals happens through BMS only, the battery management system only. It is a wall around a battery which takes care of complete battery health and its operation. Similarly, for charging condition also, if you are charging a battery, every power or signal passes through battery management system alone. That is how it works, right? So with this, let's understand what are the different functions of battery management system. The first and foremost is the monitoring of battery. That means it monitors the individual cells, it monitors the battery health, it monitors the battery temperatures, different temperatures, because a battery consists of multiple cells, right? Sometimes 100,000 cells. So it's very important to monitor each and every cell, how they're performing, right? Their temperature, their voltage, and as an overall battery pack, what is the current levels of battery. Apart from that, BMS has fundamental function of doing the estimation. We'll talk about more about what is estimation, what is not measurement, right? So state of charge, like how much my battery is charged, 10%, 20% or 100%. That's a basic function of a BMS. Apart from that, BMS also takes care of battery health, right? It measures what is my health of the battery, is it good or bad, it is aged or not aged, and other things like state of energy and state of power. There are some fundamental things as well what we talk about as control. We said, right, the battery management system takes care of it, what goes inside the battery at what comes out of the battery pack also. That means it controls the charging, discharging, and cell balancing. So whenever the demand of current is much more, right, the battery management system cuts off. It does not allow the battery to discharge more than its permissible limit. As well as, for suppose your phone is fully charged, right, or battery is fully charged, so battery management system only takes care of it when to cut off the charging. Imagine you've kept the phone in the overnight charging, right? If you keep on dumping the charge, the charger is kept on, even if the battery is 100% charged. So the battery management system is prime responsibility to not overcharge it. Don't go beyond a certain value. That is the role of battery management system. So this is a control algorithm which are built inside the battery management system. Apart from that, all those things combined become protection algorithms. So that, as I mentioned, the overcurrent should not happen. You should not be charging at very high C rates or discharging at very high C rates. There should not be any over voltage, under voltage, or over temperature or under temperature. That is how the BMS protects the battery pack from many misincident like fire, short circuit, like that. One very fundamental and important aspect of battery management system is communicating all this information to the VCU or to the vehicle level. That means when the battery management system is monitoring or estimating all these parameters, it communicates those effectively to the vehicle control unit so that other decision can be taken. For suppose, if the battery health is not good, it should be communicated to the vehicle or to the telematics unit so we can take appropriate action. Or if the battery is overheated, so I should not charge the battery pack, right? So who will communicate this information? The battery is overheated. That's the prime responsibility of BMS. So BMS communicate all the information about complete battery pack and its cell to the vehicle control unit or the vehicle unit, whatever is there, right? It monitors all the conditions. If something goes wrong inside the battery pack, it is prime responsibility of BMS as well to communicate those conditions, right? So why battery capacity cannot be measured? Now, if you see, this is a question in our video also which we posted. Unlike a fuel tank, right, where it has a physical liquid, which is a visible liquid, we can directly measure the level of that liquid by measuring the height of that cylindrical volume, right? So if you know, you can easily measure how much volume is there of a fuel inside a fuel tank. But that is not possible, right, with a battery pack, because the charge is not a visible quantity. And if you are discharging a battery, does not mean the battery becomes lighter, right? If you see your phone in fully charged condition and discharged condition, the weight is not different, right? Similarly, like it does not happen that you have charged your phone fully and your phone becomes heavier, right? So it is not such a physical quantity, because electrons, when they get transferred, it transfers from one state to another state, from anode to cathode, right? In this process of charge transfer, you generate the energy. So there is no physical measurement on the battery pack that, okay, you can measure this level and you can understand what is my capacity left in the battery pack. This is something very important. That is, it's mentioned the estimation, not measurement. So that, or we always say that SoC estimation, because you cannot directly measure how much level of charge is left in a battery pack. This is something very important which you should understand, which is fundamental, which decides why we are doing what we are doing, right? Let's understand in more detail. So at the end, if you cannot measure it, right? So how will you come to know what is my battery pack charge? What is my battery pack charge, in a sense, how much battery is charged, 20%, 50%, whatever you see always in your phone or electric vehicles, right? If you cannot measure it directly, there should be some ways by which you should know these parameters, right? You have to estimate these parameters. So how will you do that? One of the prime method, or the foremost method with which started, was Coulomb counting, right? So what happens, this image you have shown in the previous slide also, let me just take you through, right? So when the current is getting transferred, there is a current sensor, right, which is measuring how much current is being passed, right? So if you just represent the same thing in a circuit form, you see there is a system load and the current is being transferred from the system load via battery. And if you see, current is nothing but the rate of change of charge, right? and you have to measure the state of charge. You have to measure how much charge is left in my battery pack. So if you just integrate this current over time from time t1 to t2, you understand how much charge has been transferred also, right? With this fundamental principle, you see that when you do the integration and divide by the actual rated capacity, and you add in an initial charge, like for suppose I started with a 50% charge, with charge in terms of coulombs we're talking about, right? So we started with 50% charge and we discharge the battery pack and we integrate it over, right? And after some time we can just integrate this current and we can know how much charge has been transferred out of the battery, and based on that we can estimate at certain time what is my charge is left on the battery pack. This is how the Coulomb counting algorithm works. But you'll say, okay, this is flawless. So what is the issue with this? This works, right? But there are multiple flaws in this, right? The first and foremost flaw is the capacity does not remain same. If you see the capacity of a battery, right, it changes with respect to different C rates. That means if I'm discharging a battery pack at a very high C rate, that means the capacity will change. Now, if I'm discharging at 1 ampere, what is the C rate? Is the rate of discharge, means 1 C is something around 1 Ah, right? Like based on capacity. Now, if you compare that in very simple language, if I'm discharging this battery pack at 1 ampere or discharging at 10 ampere, the coulombs will not change, right? Based on this algorithm. But if you see this, the capacity changes drastically with respect to my C rate. So if I'm discharging my battery pack at a very high C rate, the capacity become almost half for this particular chemistry as compared to if I'm discharging my battery pack very slowly. This is something very important, and Coulomb counter cannot capture this very easily, right? There are some other things we have to do for this. Similarly, the battery capacity also changes with respect to temperature, right? So when you are measuring your Coulomb counting at very low temperature or measuring at very high temperature, the capacity will also change. So these are the challenges. First, last and foremost is the sensor. Since charge, again, we are not measuring it directly. This is measured via some sensor, right? So we have some kind of current sensor which we are putting in the circuit to measure the current. Based on the current, we are estimating the charge. No sensor is perfect, right? There are some drifts, there are some errors, there are multiple ways we are measuring the current: inductive sensor, Hall effect sensor, right? We have shunt resistance, shunt sensors and all. All these things have inbuilt errors in it. So when we see these errors, they get compounded and that results in much more errors. This is something which is not good for you, because if you are solely relying on a current sensor, what will happen? Over the time, this will drift because the error will keep on compounding because you're doing the integration, right? So if for suppose 0.01% error is there in the beginning, it will keep on compounded with respect to time, and that will lead to the failure at the end, right? Because then for suppose the battery is more than 100% charge, already 100% charge, but the sensor does not, or your algorithm does not know that, it will keep on putting more charge and the battery short circuit will happen. So there are some inherent challenges with Coulomb counting method. With that, we come on the OCV versus SOC curve method. In that, we know that there is a voltage sensor across the terminal of the battery pack, and based on OCV or SOC curve, we can see if I measure the voltage across this, at a given point of time, if my voltage is this, correspondingly, I can know what is my state of charge, right? This is a very simple technique. Now, again, this is also not very straightforward. This has its own limitations, right? What are the limitations with this? First and foremost limitation is the open circuit voltage is measured at rest. While the battery is in operation, you cannot have this, right? Because the open circuit voltage fluctuates. You cannot measure at the when the vehicle is in condition, right, moving condition, or the battery is in working condition. Apart from that, again, the open circuit voltage changes with respect to C rates. If you see, the open circuit voltage is not a constant number. It changes how the C rates are changing. As apart from that, the open circuit voltage changes from discharge to charging. So charging condition, the open circuit voltage is different. Discharging condition, the open circuit voltage is different. These are the limitation of this method. That is gives the rise to the other algorithm. So if you see, we started with Coulomb counting method, right? This is how the evolution of the algorithm also happened. It started with Coulomb counting method, then open circuit voltage lookup table, So if you see the Coulomb counting needs very minimal data about the battery pack like capacity and all, then it started with the open circuit voltage method where you are getting the open circuit curve and all OCV-SoC curve. Then it gives the need for the more advanced techniques so that SoC estimation can work like model-based techniques. In the next slide, now Lokesh will take you what is battery modeling and how it is done. Over to you, Lokesh.
Yeah, thank you for the insights, Vishal. I hope I'm audible. Please confirm. Uh, Let me share my screen. Vishal, can you stop sharing your screen? Vishal, can you hear me?
Yes, Lokesh.
Can you
You're
stop sharing your screen? I'll share my screen.
sure.
So, right. Yeah, I can share my screen. Please let me know if my screen is visible. Can you see my screen?
Yes.
Quickly checking. I'll be switching between two screens. One would be this MATLAB screen where we would be implementing 2RC model, and other would be the presentation screen. So I hope both the screens are visible.
Yes, Lokesh, visible. Go ahead.
Yeah, thanks. Okay, so again, hello everyone. So yeah, after the insights given by Vishal, I think it would be pretty clear that model-based approach is quite sensible for SoC estimation. For the flow sake, quickly summarizing, uh, we need to operate batteries within certain voltage range, right? Within a certain temperature range, right? And SoC is very important. SoC is not only for displaying how much charge is left. SoC is sort of a virtual boundary which also ensures that your battery is never overcharged, never deep discharge. It is also a virtual boundary which ensures that your health of the battery is maintained well, right? Because you ensure that you're not charging above 100%, which actually it can be, but you stop at that point, right? You are not discharging below 0%. So within that voltage range operation, you are ensuring that your health is extended, right? Or let's say optimized, right? So SoC is useful in many other ways. Indirectly, we are using it for various other things, right? Health and what we say, the safety part, right? And to do SoC, Vishal told that Coulomb counting is one of the methods. Yes, it is very sensible. It's quite simple also. But as we understood, the main blocker is the sensors. Sensors are not, very ideal. If let's say 5 amperes is flowing through the cell, it will not always precisely and accurately give you 5 amperes. It will have noises, it will have drift, it can have other errors, calibration issues and stuff. So the measurements are not right, so integration can lead to drifts in the SoC estimation, right? Similarly, the OCV SoC method, you cannot always have the OCV measurement through your voltage sensor. Why? Because there is, along with OCV, some drop in the cell, and that is through its impedance. So how do we know these things? These two methods are not enough. We need to have model-based approach. So that is what we will cover in next few minutes. I will go through some slides and then we'll switch to MATLAB screen where we'll be doing this kind of implementation. Uh, in this session, a heads up, we are not covering 2RC modeling in detail. It takes much more time, but enough feel will be given to people here so that uh, I mean, you would have a feel that what we will be covering in our battery course. Okay. So if we look at this implementation, which is a snapshot of a MATLAB window, this particular section, this voltage, this is actually the OCV element. We have to put cell OCV. Okay. So how do we get this OCV is one thing for the modeling, right? And these resistances and capacitances are the the complete impedance of the battery. Okay. So how do we get these resistances and capacitances is another thing. Point number two, right? So one by one we'll go through how we get these two things, right? So these are the prerequisites actually for the modeling. So one is OCV-SoC test, which we perform on cells. Okay. These are the steps, but in nutshell, first I'll tell you what we are trying to do. We take a cell which is at full voltage. Let me take a pointer. Yeah. We take a cell which is at its full voltage, 4 volt. Okay. Then we discharge it through current pulses. Okay. These pulses are of some predefined seconds. Okay. So it can be 30 seconds, 50 seconds, based on what kind of characterization you want. Okay. So once we give a pulse, there is a dip in voltage, and once the pulse is over, it goes back to 0 amperes, and then there is a relaxation in the cell. Okay. This is typical character of a cell. It's not like this is what we are doing. When you give current like this, it will do like this. Okay. And this is repeated till you reach the minimum voltage of the cell. Basically, you discharge the cell through this repeated current cycles. Okay, so these are the steps which we follow. We prepare the battery pack, we stabilize it so that the voltage is stable before we start the test. We measure the OCV. Ultimately, we are doing it to measure the OCV, right? So these are the values. The stabilized voltage values are the OCV values. Okay. So then we do that cell discharge. It can be at C by 20, C by 5, depends on what kind of characterization you want, and cell to cell also it varies. Okay. So these steps are executed regularly, and you measure these OCV values. Okay. So these OCV values are recorded, and this is what we feed over here in the model. Okay, how we implement this model, we'll be doing it in some time. Okay, so yeah, this is OCV-SoC test which one can perform in their R&D in a lab, right? And even the cell manufacturers provide this data. Okay, then the other part where we need these resistance and capacitances values, for that we perform HPPC test. Okay, where if you see this red plot, it is a current pulse. The pulse is given in positive direction, and then in the negative, basically charge and discharges. Okay. So what you see is when you give these charge pulses, charge pulse and discharge pulse, the voltage of the cell varies in this sort of parabolic way. Okay. This is something which we want to capture and understand why it is happening. Okay. So when you do these tests, you do it again from full voltage till the minimum voltage. Okay, you fully discharge the cell. So this is one of the one cycle you repeat it throughout the voltage range. Okay. Now, why do we do it, and what do we get from it? Okay, so when you discharge a cell, here we see a discharge character. So a pulse is given to the cell, and then you get this kind of voltage profile. Okay. This parabolic shape is happening because of the impedance inside the cell. Okay. So from this parabolic shape, using the equations, the RC characteristics equations, we can derive the RC values. Okay. So this test helps us to get the RC values. One might have a question, why don't we put an inductor? Uh, Again, we have to understand the reason behind putting RC model. The intent is we want to do battery modeling. Why do we want to do battery modeling? Because every time we cannot make a physical battery and do algorithm testing on that physical battery. If the algorithm is not working fine, the battery is, it goes into waste, right? So, and it also takes it increases our development time. So doing it in simulation is more sensible. So in simulation we want to mimic our battery. So it depends how you want to mimic. 2RC model is one of the more popular ways to do it. There are other ways also to mimic it. You can uh, take approaches like empirical method, where you just characterize, you get some data of a cell and then put it in some tabular form or some equation form. That is also a way of modeling battery pack. When you say 2RC modeling, resistance and capacitance, these two things are coming, not inductance, because when you demand current from a cell, which you can see here in the red pulse, it immediately gives whatever is demanded. Okay, the rise of current is immediate, right? But When it comes to the voltage from the cell, it doesn't rise or fall immediately. There's a parabolic shape, right? So to mimic this immediate rise in current, but not so immediate rise in or fall in voltage, we need capacitances and inductance. Okay, inductance is not used because the current is rising immediately. If the current also had been rising or falling parabolically, we would have put an inductance also. Okay, or in other words, let's say if the voltage also had been rising immediately or falling immediately, we would not have used a capacitance. Okay, so capacitance is used because voltage has this parabolic shape, right? Inductor is not used because current immediately falls, right? The other thing is why resistances are used. There is a rate at which it is falling, and falling word is there, right? Voltage drop is there. That is happening because of resistance, which is there along with the capacitances. Okay, so I hope why we call it 2RC model, why resistances and capacitances are there is clear. Okay, so these two tests help us putting the values of OCV here and resistances and capacitances here. Okay, more details of how these tests are executed, each and every step we'll be covering in the course. Okay, this is how the 2RC model looks in generic form. We have resistance. This is series resistance. These are the RC time constants. I'll be explaining it in few seconds why this kind of arrangement is there. So let me take a pen and yeah, right. So if I plot current, this is a current pulse which we demand. Okay. So what do you see? Voltage changes or voltage behavior with respect to this current pulse is something like this. It is stable here, right? Point 1, it is stable. Then there is an immediate fall in voltage. This is point number 2. Okay. Then after that, there is this kind of curve. Okay. This is response 3. And once the current is back to 0, it rises back immediately. Okay. I'll call it 4. And then it goes back and settles something like this. Okay. Let's say it settles here. So this is response 5. Okay. Now, ultimately, again, repeating, we need to mimic this behavior, right? So 1 is mimicked here. Okay, this 2 current is going through this circuit I. So this resistance can mimic this immediate drop, right? So 2 is mimicked here. Now this 3, it can be mimicked through R1C1 only, but the accuracy would be probably lesser. Okay, it might be probably 95%. So when I say accuracy would be lesser, if the real response is like this, you might get something of this sort. Okay, so it might not overlap properly. It might be something like this. Okay, so for that reason, to improve the accuracy from 95% to let's say around 98%, these are intuitive values. So in reality, it is something like this only. You use another RC combination. Okay, so 3, the whole response 3 is coming from these two RC circuits. Okay, so these resistances and capacitances are mimicking this voltage behavior, right? Now, in certain cases, for certain use case, we might want 99.5% accuracy or something, like close to 100. So in those cases, we can actually put one more RC in the circuit. So that can be R3C3. So this would be a 3 RC circuit from 2 RC to 3 RC circuit. So it depends on what accuracy you want, right? If we are doing a device which is required in medical field, which is doing a very crucial used for very crucial application, maybe 99 plus accuracy is required, so you probably would opt out for a 3 RC model instead of 2 RC. But in automotive industry, 2 RC is mostly used. Okay, so I hope it is clear how these RC circuit in the circuit are playing their role to capture this cell behavior. Okay, so now this is We'll implement this in MATLAB window. Okay. Let me switch to MATLAB. Right, I have already kept it implemented, but I will just show you quickly how we do it. You people who are not very familiar with MATLAB, we will be having a few sessions on MATLAB also to give a decent base for you to work on MATLAB. Okay, so you have your MATLAB window like this. You click on Simulink. This is how it looks here, and then you get MATLAB window here. Sorry, Simulink window here. So we just have to implement this circuit. That this part is not tricky. Okay, so you just have to, 1 second. Just give me a second. Just have to implement this circuit, right? So yeah. So you go to library. There are all these libraries have different block sets. Of our interest to implement to RC circuit, it is Semiscape, which you have to go to. Okay, and you get the elements here. So you click on Semiscape, you get Semiscape electrical, and in this, if you click on this, you'll get capacitor here, right? Inductor, sorry, capacitor, inductor, resistances, all these. And one easier way to do it is you just have to click on this white space and type voltage. Okay. So when you type voltage, you will get voltage source, for example. So that is how I get voltage source here, right? And then if I want register, I will just click on register, right? And then connections happen like this, okay? If I want capacitor, yeah. So right click, drag. This is how I made the circuit. I hope this surely looks pretty simple. The implementation part, how we use it is the important thing, right? How to put the values, you can double click and put values here, right? You can put values like this, or you can put table here, OCV-SoC table. Similarly for the resistance, capacitance, you can put values here, right? So this is how I implemented this circuit here. Why these things are there, I would say park it for now. In the course we will understand more in detail why these are sort of prerequisites of MATLAB, to do this simulation, right? uh, Through this arrangement, I am trying to do this current pulse behavior. Okay, so I'm trying to draw current from this circuit, this highlighted circuit. Okay, so this is our 2RC model. I'll just highlight it like this, right? Through this arrangement, I'm trying to mimic the current pulse. Okay, and then we will be measuring voltage, right? So if I simulate this thing, right? I double click. This is the current pulse which I gave. Okay, 0.5 amperes. And what you see is voltage drops immediately. And that is because of the series resistance RS, which we saw. And then it falls further. It's not a straight line, it's exponentially falling. Okay. And once again, when it is in back to zero, the current, there's this jump because of RS, and then R1, R2 is happening. Okay. So one more quick thing I wanted to explain. Let me take a snipping tool here, and sorry, I'm a bit old school, so I always use pen and manually explain things. So yeah. So as we understood, this is our OCV, this is our RS, this is our R1. I'm trying to give a feel of it. As I said, detail of the whole thing, model implementation will be there in course. But yeah, feel of it is what I'm trying to give. So yeah, this response we understood is because of RS into I. Here is the I, right? Two things I want to capture. One is why we are giving pulse, why not any other shape of current. Second is what is the significance of RC. In one way I have already explained, resistance is there to capture voltage drop, capacitance is to capture the this dynamics of drop, okay, but there is a significance of this R into C, okay. First, why pulse is used? Pulse is used because we want to characterize the cell, right? This is one of the methods, right? This is the second method, HPPC. See, when it comes to characterization, we try to understand a system's behavior at different frequencies, okay. There's something called frequency analysis, okay. And when we do frequency analysis, we try to understand systems behavior at different frequencies. And when I say different frequencies, the relevant frequencies. So to do this, we would need multiple sinusoidal signals of different frequencies. So we will be actually giving these sinusoidal inputs. So we can actually give sinusoidal current pulses, okay, of different frequencies, like all the frequencies which are of our relevance. That is one of the ways to do it. But the other easier and more robust way to do it is giving a pulse. Why? Because this square pulse is equal to infinite frequencies. Okay, this is a combination of infinite frequencies. So indirectly we are capturing the system's behavior with respect to all the frequencies. Okay, so that is why we are giving pulse. Second thing, how do we understand this RC more technically? RC is actually called as time constant of a system. Okay, in detail, if people are not familiar with this word, you can, we'll be covering it in the course. So time constant is something like how much time a system takes to reach its final value target. Okay, one time constant is around 63% of the final value, right? So what we understand here is, if I had opted only for one RC, this, or I would say it in this way, this response from here, point A to point B, let's say it settles here. This response can be broken down in two time constants. One is a curve which goes like this, okay, and another could be a curve which has a different rate of movement. Okay, so this is something which is happening from R1C1, and this other thing is happening from R2C2. Okay, so when we discuss this RC model more technically, we don't say that R is there for drop, C is there for the rate of change. That's then a bit, basic way of discussing things. It is discussed in terms of time constants. Okay, so I hope a better idea is there why we are doing these things, right? So yeah, this is a typical simulation of 2RC circuit. And once we have this model, we have battery in place, right? Now we can develop various algorithms. It can be SoC algorithm here. It can be SOH algorithm here. Because we have battery, it can be safety algorithms around it, right? So once these algorithms are developed on this simulation battery model, we can put these algorithms, we can generate code from these algorithms and put it on actual battery pack or actual vehicle, right? So this is how you do the whole, this is how the development cycle is. One more thing, as we have understood, there are different approaches or modeling approaches. Even in 2RC modeling, it's not only that you have to have these circuits. As I said, when we do technically approach these things, frequency domain analysis and stuff, we prefer doing equation-based modeling. Okay, this is good to know, but more sophisticated way of doing things is doing it through equations, so that we understand the stability behaviors, the corner cases, the dynamics of a system better, right? So this is an implementation where I'm trying to give a feel of how equation based implementation happens. So what I've done is I have put a circuit where resistance and capacitance are arranged like this, and the same thing I have mimicked through equation. This is a transfer function, so this is Laplace domain equation based implementation of this circuit only. Okay, and what I've tried to do here is I'm trying to show that how this equation based implementation is same as this circuits behavior. Okay, so just a second. 5% is, so I've just simulated it. And if we see the response, what we can see is what we see is both the responses are same. So that means that element based implementation can be done through equation based implementation. It would become slightly trickier to do that, but then life would be easy when we are trying to implement algorithms, because with these equations we would be able to do better analysis in terms of how system behaves with respect to different frequencies, the corner stability analysis, and the dynamic behavior of a system. Okay, through these elements it's trickier to figure that out. Okay, so yes, equation based implementation is the way to do it when it comes to RC modeling. It becomes trickier, but the life is easier when it comes to developing these algorithms around the model. Okay, so yeah, this is what I wanted to capture from my side. Going back to, yeah, the presentation. Right. So I hope a decent feel is there with all of you, that why do we do modeling, uh, how we do it, and how it is useful to develop various algorithms. So as Vishal told, Coulomb counting is there, open circuit voltage based method is there. But once we have these model based approaches, let's say we have RC circuit, we can have hybrid approach where we can combine these algorithms together and then come up with a more sophisticated way to estimate SOC. Okay, there are more approaches like chemical impedance model, or neural network based, data driven based. Those things also will be covered in the course. Okay, and as I said, model of battery is not only required for SOC. Once you have battery model, once you have a battery mimicked in simulation environment, you can use it to develop various other algorithms: SOH algorithm, SOE algorithm, power algorithm, function algorithm. When I say function, it's like all the safety algorithms can fall in this, right? So that is how battery model is very important, and that is how 2RC model has become very popular in history. Okay? Yeah, I think, yeah, that's all from my side. I hope we have a decent feel of RC modeling and the need for it. Over to you, Vishal. I'll stop sharing.
Yeah, thank you, Lokesh.
Yeah, thank you.
Let me share my screen. I hope I'm visible and audible clearly, right? So a very wonderful presentation or a hands-on demo by Lokesh on this. And let us also give you a brief about what is Techlanz, because we are keep on organizing these kind of webinars for sharing on education perspective so that everyone in the community learn more. We have open source community also. So let me brief about it. What is Techlanz at the first place? So Techlanz is a open source community or a global ecosystem of electric vehicle. We have training programs from the industry experts. We have actual hardware which we give you along with the programs so that you can test and practice on actual hardware. We also provide you engineering services. We have engineering services vertical with many industry experts with us, from software, MBD, system engineering, hardware development, testing, and all, right? We keep on doing these kind of webinars. Apart from that, we also arrange the webinars with our industry partners. So we have very generous industry partners who help us whenever they launch some new product or some new technology, they come on board and they present their technology advancements in the field. So we have very generous partners with us also, and we also conduct these kind of webinars for the knowledge sharing. We also have a global EV engineering community, which we are developing. We have both the community WhatsApp as well as an online community for sharing the ideas, sharing the knowledge and all. You can compare this one Stack Overflow for a core engineering domain. Stack Overflow is for, suppose, your IT industry, right? Yeah, everyone wanted to go to an answer. You find that answer in the Stack Overflow. But hardware is hard, right? And it needs so many people and from different domains. So specifically for electric vehicle engineering, we have developed this global community, right? You can visit us on our website, Techlanz, www.techlanz.com. You can join our EV community, a WhatsApp channel. I'll share in the next slide. Okay. We have online community also, like a web platform for discussion on the engineering topics related to electric vehicle, be it software, be it hardware development, be it testing, anything related to vehicle, we are there, right? We have other courses also, which we are offering as a part of our programs. As I told you, we have different verticals, and engineering course or training programs is part of one vertical, right? So what I'll do is I'll share this details with you on the chat box so that you can reach out to us for any website, for any training programs or services, or you can also join our community, open source community, right? Let me just share this on the chat box, then we'll be open the podium for the question answers. Just 1 second. So let me first share this with you. On the chat so that you can access all the resources with us on the platform, right? You can visit our website.
It's already shared, Vishal.
Lokesh has already posted it. Thanks, Lokesh. I think it was missed from my side. That's why I ended my presentation. Okay, let me go back to the presentation again then, right? We'll come back. Yeah. Okay. So now the podium is open for question answers. You can ask any questions live, right? And it is important that you can brainstorm around it. You can ask any questions what you have regarding our programs. So if you see, we are offering our first program, Battery Plus BMS Bootcamp, which we are offering. And again, we are offering, see, there are many trainers and mentors with me, Lokesh, Amit, Ravi, Suraj, they are training. And Techlanz, we have multiple advisors also. We have 10 advisors, which are more than 10 years industry experience, right? You can read about the courses by visiting this course website and our services also. Any questions, please raise your hand. I'll allow you to speak. You can ask it live in the session. Multiple questions were posted in the chat box, which we have answered. If something is not being answered by us, thank you, Mithun. Thank you for the wonderful feedback. If any questions are there, you can please feel to ask other questions also. Right? If we don't have any further questions, maybe you can visit the website, go to the course brochure, or maybe the course page. If you are interested in the course or services, take a minute to do so. And if you have any other question, you can ask live right now itself. If everything is done, there's no more questions. We are on time. We are right on time. We'll close the session. Right. So Lokesh, you can unmute also. Thank you, 𝐓𝐨𝐻𝐬𝐤𝐜. Thank you very much. Is the course online or offline? So we are providing online course, weekend program, but the hardware is given to you, right? that's a weekend program, so that we are ensuring that all the working professionals are a part of this. We believe that if the working professional and students both are there, you get the curiosity and inquisitiveness by the people who are there from the student background. Meanwhile, if the industry professionals are also there in the program, you get to know what is happening in the industry. So mix of both are part of that, right? The one question, I think one participant want to ask Mr. Balakrishnan Durgam. Please unmute and speak, Mr. Bala. I have allowed you to speak. Can you please unmute and speak? Mr. Bala, you have raised up. Yeah.
Sir, hello, sir. Yes.
Yes, please go ahead.
Yes, sir. Yes, sir. Fine to see you again, sir. Actually, it's a good platform for sharing the knowledge and also skills. Everything is good, sir. And recently, I go through the I go through this. It's a nice program, sir. You have started a. Hello. Maybe you can hear
Yeah,
me,
thank
sir?
you, Mr. Bala. Thanks a lot for your wonderful feedback. Thank you very much. We keep on doing these kind of thing because this is
Yes,
something
sir.
that's very close to our heart to
Yes,
educate
sir.
people and train them for the future.
Yes, sir. Yes, sir. This kind of webinars and also skilled persons training is also need because today the world is today means India is going the trending in transportation trending is going to a tremendous change in future, sir. So skilled persons are needed. So this is the right time to skill the for for the filling the demand means skilled persons.
Correct. Yes, that's our thought process also, Mr. Bala. That's why we started this, and we'll keep on doing this. Uh, so that's why we have some kind of snippet on the future, how the platform is evolving, how the EV industry is completely evolving.
Yes, sir. Yes, sir.
Yeah.
Very happy to see you. I am really happy, sir.
Thank you very much. Thank you very much.
Okay.
Mr. Shetu, 1 second. Let me. Yeah, you can unmute and speak.
Sir, good afternoon.
Good afternoon, Mr. Shetu.
Sir, actually, I just wanted to know regarding the values of R and C from the HPPP test. Is there is a general formula or some thumb rules to have to formulate the values of R and C for the RC modeling?
Yeah, Lokesh.
I'll take that. Right. So there are certain thumb rules which we follow when we do HPPC test. Even HPPC
Lokesh,
test,
turn on camera. You can turn on the camera.
yeah, even HPPC test can be tweaked, or let me say it is tweaked, from cell to cell and from application to application. So there are some thumb rules which we will be covering in detail, and with those thumb rules, yeah, we perform the test and derive the RC values. Does it answer your question?
Yeah, actually, I got it, but just wanted to know if we can have some idea about that. As you told, it will be covered in the
Yeah, so
course.
as I said, one of the things which I mentioned was why do we do a pulse, right? Uh, Now, pulse is done to capture various frequency behaviors of the cell, right? Now, those frequency behaviors in detail, we'll have to get into frequency analysis, what transfer function is, right? So, in this short duration, I'm sorry we cannot discuss that, but to give a feel, to HPPC test, we do these analysis, RC values derivation. There's something called a parameter estimation, which we will be covering. So once we have the curves, we do parameter estimation, and that is nothing but RC values estimation. And then once we have RC values, we put it in equation form, the transfer function form, and then we do frequency domain analysis. So in short, through HPPC test, we do two things. One is parameter estimation, and then other is the equation based modeling, which we use for various transfer function based analysis.
Okay, sir.
Yeah.
Thank you.
Thank you. More questions?
Yeah, I think it's time to close, Lokesh. I think we have answered most of our questions.
Yeah.
And thank you very much, participants. It was wonderful having you all over here in today's session. And we continue to serve you with these kind of sessions. And we also are a technology provider, right? So we are a technology company. You can actually go through our courses, our training programs, or community, or our engineering services, and let us know how we can help you more with this. And we want every one of you to gain the right skill set which is needed for the future mobility industry, be it software, be it hardware, right? If any last questions in last 30 seconds, or else we'll close for the day. Mr. Chetu, you have another question? Okay, let me allow you to speak.
Thanks a lot, sir. Just wanted to know, suppose if we want to meet you people in person, where is the HQ, or suppose we need to discuss about some business opportunities, that I wanted to know if it can be have a face-to-face meeting or something like that for any industry or any person who needs a solution regarding that. Where is the HQ and all that?
No, our headquarters is in Bangalore, so you can reach out to us, right? I
Okay.
have messaged this one. You can send a mail also to us,
Right.
contact@techlanz.com. So we
Okay.
can definitely help you with that. So
Okay.
we are providing all kind of engineering services. You can go through this one. Some things are not mentioned on our website, just not to overwhelm people, like, because we provide services in vehicle development, also testing, also and all. Not everything can be mentioned on the website. So you can just send us a requirement over the mail, and we'll come back to you with that. It will take some time
Sorry.
to us, maybe a week or
Right.
something,
Yeah.
to revert to you, because there are so many inquiries which are coming us now, right? So kindly
Mhm.
allow us, or you have our phone number, which is also mentioned. You can call us directly on this phone number. We'll discuss with you.
Okay. So it will be better if we can have that in the WhatsApp box, these numbers and the mail IDs.
This is on a WhatsApp. This number also and mail. Actually, you are asking us to send on a WhatsApp group community.
Yes, yes, yes. The
Sure.
one in which we received the link for this webinar.
We'll drop it over there. Sure.
Yes, that will be better.
Sure.
Right, sir.
Thank
Thank you.
you.
Thanks a lot, sir.
All right, I think we can close the session, Vishal. Thank you, everyone. And
Okay,
feel free
Lokesh,
to
let's
put
close the
more
session
questions.
then. Thank you
No
everyone
worries.
for your wonderful participation, and we are obliged that you all joined us in today's webinar, and we are happy to help you or anything, be it courses or be it services. Thank you very much.
Yeah.
Winning farewell from the Techlanz. Thank you very much.